In looking at this lesson, it's the same things in the rectangular fraction model as we were doing last week. If they were doing 1/2 of 1/4, then you would take the rectangular fraction model, put it into fourths, shade in 1/4 of it. Then you would put it in 1/2, go the other way, and then shade in 1/2 of it. Now you see they only do this one, that one little piece, but I always just go all the way across. And then I look at the one that is double shaded. So then you've got your answer, that the one that is double shaded, you've got 1 out of a total of 1, 2, 3, 4, 5, 6, 7, 8. And that's how that works. I'm just reminding you how the rectangular fraction model works. Can you please sit all the way down? Then with standard algorithm, 1 times 1 is 1, 2 times 4 is 8. They should match. So with these, they're doing a unit fraction times a non-unit fraction. And all non-unit means is that the numerator is not 1. That's all it means. Unit means the numerator is 1. Non-unit means the numerator is not 1. That's all it means. So the first one they did for you, 1/2 of 2/5. So they did a rectangle. They split it into fifths. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. This time they're shading in 2 out of the 5. 1, 2, 1. So 2 out of the 5 get shaded. Yeah? Okay. Then they need to go 1/2 of that. So I'm going to go the opposite direction. So I'm doing the same exact thing they did here. I'm just showing it how it was done. So now I'm going to go this way. And the only ones that are double shaded, you see, I'm not like coloring it in all the way because then it's hard to see it. The ones that are double shaded, this one and this one. So I've got 1, 2 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10. Then what they did right here is they simplified it. Because 2 can go into 2 and 2 can go into 10. That's how they get 1/5. Simplifying fractions is not new. We did that last quarter over and over and over. Now, whether or not you decided to remember how to simplify fractions, it does not go away. 1/3 of 3/4. I'm going to do my rectangular fraction model, and I'm going to put it into 4 sections. 1, 2, 3, 4. So 4 sections. How many of them am I going to color in? 3, because it tells me right there, 3/4. So I'm going to color in 3 of them. And I'm not fully shading, I'm just doing lines. Plus it's fast. So 3 out of 4. You going to do this too? This is 8. So 1/3 of 3/4. How many sections are we going to have going this way? 3. It's not always going to be a half. So 1, 2, and 3. Now I've got 1, 2, 3 sections going the opposite direction. How many am I going to shade in? How many am I going to shade in? 1. We just started. How many are double shaded? 3. 1, 2, 3. Out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can that be simplified? By what? 3. Can 3 be divided by 4? 4 can go into 12, but can 4 go into 3? No. No. 3 can go into 3. 3 divided by 3, 1. 12 divided by 3, 4. Now if you do the standard algorithm, let's see, 1/3 of 3/4. All I want you to do is break it down again. I don't know why, it's just kind of silly. 1/3 times 3/4. 1 times 3. 3. 3 times 4. 12. Same thing. Standard algorithm, matching the picture. 3/12 is equal to 1/4. So 1/3 of 3/4 is equal to 1/4. Because you see, they don't even give you an option to put 12. It's 1/4. It is a little hint. Because if you try to put 3 right there, because if you're not paying attention and you do 1/3 of 3/4, 1/3 of 3/4 equals 3/4, is that right? No. 1/2 of 4/5. 1/2 of 4/5. Do your rectangular fraction model. So I'm going to do how many sections?
4,
5. 1, 2, 3, 4, 5. How many are shaded? 4. Were you going to do the opposite direction?
break it
Like, break it into half. Why?
because it's of 1/2.
1/2. It's got a 2 in the denominator. And then you're only going to shade in half of it. How many are double shaded?
4.
1, 2, 3, 4. Out of
20.
how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4/10. So is 1/2 of 4/5 equal to 4/5?
No.
No. So what does that tell me about 4/10? It can be simplified by what? 2. Cannot be simplified by 4. 2 can go into 4, and 2 can go into 10. 4 divided by 2 is 2. 10 divided by 2 is 5. 2/5.
What?
And I have Boo's paper clip.
Oh.
Okay, 1/2 of 2 halves. Anybody look at that one and go, what? Darn. Okay. How many pieces? How many pieces? 2. How many are shaded? 2. If you break it down and look at what's there, it shouldn't confuse you. I mean, really. How many go in the opposite direction? 1, 2. How many are shaded?
1.
Andrew, do you need something? What? Why are you facing that way? So, how many are shaded? 1/2 of 2 halves. So 1, 2, out of 1, 2, 3, 4, 2/4, which is the same thing as 1/2. If I do standard algorithm, 1/2 times 2 halves, 1 times 2, 2 times 2, 2/4, which is 1/2. And if you look at that, 2 halves is the same thing as 1 whole. If your numerator and your denominator are the same, doesn't matter what the fraction is, if your numerator and your denominator are the same, it's still 1 whole. If I have 100 pieces, out of 100 pieces, it's still 1. Doesn't matter what the fraction is. Daniel, can you put that up? How many pieces? 2. How many are shaded? 1. How many pieces go in the opposite direction? 3. How many are shaded? 2. So, how many are double shaded? 1, 2, out of 6. 2, 6. 1, 2, 3, 4, 5, 6. Which is the same thing as 1/3. Aaron, stop drawing. Because this can be simplified by 2 and this can be simplified by 2. What you do to the bottom, you do to the top. 2 times 1 is 2. 3 times 2 is 6. 2, 6. Same thing as 1/3. How many pieces? 5. How many are shaded? 3. How many go in the opposite direction? 2. 1, 2. How many are shaded? 1. How many are double shaded? 1, 2, 3. Out of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can this be simplified? I've only got one person who knows. Can this be simplified? No. There is not a number that can go into 3 and 10. Because 3 cannot go into 10. And 3 is a prime number. So 1 times 3 is 3. 2 times 5 is 10. 3/10. That's as small as it gets. How many slices? 1, 2, 3, 4. How many shaded? 1. How many go in the opposite direction? 3. How many shaded? 2. How many double shaded? 2. Out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can it be simplified?
Yes.
Yes. By 2. 2 divided by 2 is 1. 12 divided by 2 is 6. 2 times 1 is 2. 3 times 4 is 12. Five-eighths of the songs on Harrison's music player are hip-hop. 1/3 of the remaining songs are rhythm and blues. What fraction of all the songs are rhythm and blues? Now this one says use a tape diagram. It does not say a rectangular fraction model. It says a tape diagram, which is different. That's like a bar model. So 5/8 of the songs. So if this is his music player, so as much as some of y'all hate doing tape diagrams and bar models, will this help you solve the problem? Yes. Yeah, you kind of need to. So 5/8 of the songs are hip hop. So what do I need to do to this tape diagram? Divide it into 8. Let's see, I did this, and I got 1, 2, 3, 4, 5, 6, 7. Not enough, so I'm just going to add one little extra thing on there. I don't get all freaky and erase things all day long. If it's short, if it's too short, I just add a little extra square on there. I'm not going to sit there and erase things all day. So 1, 2, 3, 4, 5, 6, 7, 8. So I got my denominator, 8. 5/8 are hip hop. So all I'm going to do is take 1, 2, 3, 4, 5, label that hip hop. I'm doing exactly what the problem is telling me. 5/8 are hip hop. Now, that's all the problem has anything to do with hip hop. That's it. Okay? 1/3 of the remaining songs are rhythm and blues. So I want you to look at this. 1/3 of the remaining. See the remaining?
Yes, ma'am.
1/3 of the remaining are rhythm and blues. How many pieces are left?
3.
3. So we have 1, 2, 3 left. 1/3. So the 1, so this is the remaining. So you have to watch that of the remaining. Okay? So there were 3 pieces in the remaining. Are you seeing what the problem was telling you? There were 3 left. 1/3 of the remaining. So 1 of the 3 remaining pieces is rhythm and blues. So this one piece right here of those 3 remaining pieces is rhythm and blues. R&B. Did you see what I did? You're making a face, Eli. Okay. Do you see what I did? Sometimes there's more to the problem than this, but this one was pretty like in your face. This is why you need to draw a bar model. Because if you just did, oh, we're multiplying fractions. That is wrong. This is not it. No. It says use a tape diagram to solve. The tape diagram will give you the right answer. Multiplying your fractions will give you the wrong answer. What fraction is this 1 unit of that tape diagram? 1, that's not a fraction, that's a whole number.
1/8.
Bingo.
I said 1.
I heard 1. 1 out of 1/8. That's your fraction of his music player that is R&B. 5/8 is hip hop. 1/3 of the leftovers, because there were 3 pieces left, is R&B. Do we care what these are? We don't care. It's not important. This 1 unit is R&B. So of his entire music collection, now we know 1/8 of his entire music collection is R&B. Okay? Yeah? No? Maybe? Okay. See, you have to take, if you read the entire problem and just go blah, 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 words, you are not going to get it. If you do it, see how I drew the tape diagram, and I did 1 piece of information at a time, and I labeled it as it told me. It kind of breaks it down and makes it easier to understand what it's saying. You have to take these word problems and break it up. Otherwise, you're never going to get it. When I first read it, I was like, oh my God, I'm never going to be able to explain this. But when I took it 1 little piece at a time, it was a whole lot easier to understand. You can't just go, oh, number, multiply. Now it's wrong. You see how that is totally different from that. This is wrong. This is right. You can't just go numbers, multiply them. Sometimes it will be wrong. 3/5 of the students in a room are girls. This is a lot of information. 3/5 of the students in a room are girls. 1/3 of the girls have blonde hair. 1/2 of the boys have brown hair. What about fractions? What fraction of all the students are girls with blonde hair? What fraction of all the students are boys without brown hair?
Good brown hair.
Right, because there are 2 units. Man, we are mathing so good right now because there are 2 units, and we've got a denominator of 2, and one of them is brown. No, we looked at this problem and we felt so dumb, and now we're just like, oh, I got it. Okay, what fraction? When we first read it, we were just like, huh? And so now we're using a tape diagram that people hate, and now they're seeing the benefits of using a tape diagram. What fraction of all the students are girls with blonde hair?
What happened?
No! 1 out of 5. There's 1 unit out of how many total units? 5. 1/5. What fraction of all the students are boys without brown hair?
1/5.
So we got boys without brown hair. All the students. 1/5. Cody and Sam mowed the yard on Saturday. So is that important in the problem? No. Dad told Cody to mow 1/4 of the yard. He told Sam to mow 1/3 of the remainder of the yard. Dad paid each of the boys an equal amount. Sam said, Dad, that's not fair. I had to mow 1/3 and Cody only mowed 1/4. Explain to Sam the error in his thinking. Draw a picture to support your reasoning. So, do you think that if you use a tape diagram / bar model, that you would be able to explain to Sam why he is incorrect, why Dad is actually right in giving them the same exact amount of money for mowing their part of the yard. Would it be correct to go, oh, fraction, multiply 1/12? Would that be right? That's not even doing anything. But if you don't read the problems and go, okay, so we're multiplying fractions, so I'm going to take the fractions and I'm going to multiply them, would that even answer the question? No, that's not even what you should do. So I want to see if you can actually take everything that we've learned today and work this problem on your own without me. See if you can do this, and I'm going to come back and I'm going to revisit it with you. See if you can do this and change in just a couple minutes. Cody and Sam mowed the yard on Saturday. Dad told Cody to mow 1/4 of the yard. So what am I going to do with the yard? Put it in fourths. When we see something like this, the remaining or of the rest, then that tells me I should do something like a tape diagram or something. Because we're not doing 1/3 of 1/4 or 1/4 of 1/3. So we are not doing this. So he did 1/4 of the yard. So this is Cody. He told Sam to mow 1/3 of the remainder of the yard. So 1/3. How many pieces are left? 3. So Sam did 1 of the 3 remaining pieces. So this is Sam. So Dad paid each of the boys an equal amount. So technically, what size did Sam do? 1/4. It was just 1/3 of what was left. But they're all 1/4, 1/4, 1/4, 1/4. So let's see. So Sam said that's not fair. I had to mow 1/3 and Cody only mowed 1/4. Technically, 1/3 is bigger than 1/4. However, he didn't mow 1/3. He mowed 1/4. And if you use the picture is justification. If you use this, then it really looks like Sam did less. Because he cut something that was already cut. So Sam did the same size piece. That's 1/4.